Hey students, welcome back, welcome again. So we are back in action with Iupac naming of coordination compounds or complex compound. The name suggests complex compounds, but the naming is very simple. The standard procedure for naming any particular complex. Now let me write down a complex for you. First of all, look here. This is our complex, and if you do not know the basics to it, you must look it in the description box. The video one, that is for the basic introduction of this chapter. So you can look at in the description box. Today we will discuss Iupac naming. Now for any particular complex, this to the extreme left, it is a cation. The first species, the first element in the coordination sphere is what? Our metal, and the rest is what? Ligand. Now the naming, the standard protocol, the technique or the trick. First of all, write down the name of cation. So the cation is what? Sodium. So we will write down sodium in small alphabets. It is part of rule, small alphabets, sodium. Then we will name number of ligands. Number of ligands. Here we have 6 ligands, and ligand is fluoride, fluorine. For fluorine we use fluorido, chlorido for chlorine, ONO nitrito, OH hydroxo, CN cyanido, CH3CO acetato, NO2 minus nitrito, N carbonato, sulfato. So for number of ligand, but not name of ligand. Number of ligand, if you have 2 ligand, then it will use di. For 3 we will use tri. For 4 tetra, 5 hexa, and 5 penta. I got confused. And for 6 we have hexa. In this particular case 6 ligands are present, so the name comes hexa. For fluorine we will name it fluorido. So after number of ligands we will try to write name of ligand. After this, here we have fluorido. After this we will name our metal. But for naming of metal we have to take certain precautions. What precautions? First of all, the name of the metal can be written in 2 ways. It can be written as it is. You can write this down as aluminium, or you can add suffix ate to the name. You can write aluminate. So when to write aluminate, when to write aluminium. Now look very closely. If the coordination sphere is positively charged, then you will write down as it is. Or the second condition says the coordination sphere is there and anion is present, then again as it is. For 8 we must have a negative charge on the coordination sphere, or you can say a cation is present, then you will use 8. For this particular case, here we have a cation, this condition is satisfied, we will use 8 and the answer will be aluminate. So we will write not aluminium, we will write this as aluminate. Now look here. Here we will give some space, but in this number of ligand and name of ligand, no space is given. Now moving on to the next part, we will write down oxidation state of the metal. Oxidation state is mentioned in the brackets and in Roman language. Roman, as we all know in the previous classes. So oxidation state of aluminium. If you do not know, you haven't studied redox, look here. We have 3 sodium, aluminium and 6F. That will be equal to 0. No charge present on the system. Now if you consider this, sodium is +1, that will be 3. Aluminium we need to find, and fluoride will be -6, -1 of 1 fluorine, that will give us -6. Doing all the maths, we will get our answer +3. So after that we are going to for the bracket and in Roman 1, 2, 3 and done. So if you want to name any coordination compound, this will be your standard procedure. If you have an anion present to the extreme right, just name it after this. Name of anion. So if you know this, you won't fail in any case of complex compound. Just write down the cation, ligand, name of ligand, number of ligand, name of ligand, metal as it is or with 8, oxidation state in Roman within the brackets, and name of anion. Now the only thing left is to try some examples out of it. So I will clean this up. You can take a screenshot and do write this down before it's too late. So moving on to the next example. Now we have, let us consider KBF4. This looks nice. Or I say NaBF4. I will tell you the name of KBF4. NaBF4 is your homework. Try this and write down the answer in the comment section. K corresponds to what? Potassium. And here also write this in small alphabets. It is part of the rule. So potassium, we have 4 fluorine, number of ligand will be 4, hence come the name tetra. Then name of ligand, fluorine, fluorido. Now what should we write? We should write boron or borate. So in this particular case, we can see a cation is present, this condition is present, we will add 8, hence our answer will be borate. Now comes the oxidation state. As we all know, fluorine -1, that will be -4, potassium +1, that will be +1, 4 - 1, 3, it jumps and it will get 3. So the answer will be 1, 2, 3. So answer for this will be potassium tetrafluorido borate 3. Now try this one and we will get moving. Now let us discuss a case of anion. We have discussed a case of cation. Let us discuss something about anion. Now if you say I have AgNH3 whole twice with this Cl. This looks nice. Now for this particular case, what name we will use? Are we going to use silver as it is, or we are going to use argentate? Now for this particular case, you need to remember there are 3 or 4 elements for which we use their Latin names. For iron, for tin, for copper, and one more for this Ag and for Au. These are the cases in which we will use their Latin names along with 8. However, if this condition is not satisfied, we will name them as it is. Now look here, in this case we have an anion. Look at anion. So as it is naming, that will give us silver. So silver, this will be silver. The confusion is solved. Now the naming starts with name of cation. No cation is present. We will move on to number of ligands. 2 ligands di. NH3 corresponds to what? Amine. This is our NH3. So diamine silver. Now comes name of metal and its oxidation state. NH3 is neutral, so Cl minus, that will give us 1. So diamine silver 1. This chlorine will be named as name of anion and it is just a chloride. Do not write chlorido, that will be wrong. If you write chlorido, that will be wrong. If chlorine is present here inside the sphere, then it will be right chlorido, otherwise chloride. So I think you got it. Now the next case, try this by yourself. If I say I have K2NiCN4, name this K2NiCN4. It is what? Potassium. Here we have 4 cyanido, that will be tetracyanido because number of ligands comes first, so that will give us tetracyanido. Okay, now we are going to write the name of metal, nickel or nickelate. If you look, this condition is satisfied, a cation is present, so we will name this as nickelate. So the name comes nickelate. Now moving on to the next part, we have the oxidation state in the bracket -1, that will give us -4 here, and +2 here, that will give nickel 2. So I think you are getting my points, you are getting the thing. It is nothing. If you know this particular pattern, it is just child's play. Now let us discuss some more example. I need to clean this up a bit. Somebody tell me the name of this compound. It is a complex of gold. And after this, you can try this also. K4FeCN6 or its little brother K3FeCN6. Okay. Now let us try this. What is this? This is cesium. First A, I suppose. So we will write down cesium. Now 4 corresponds to tetra. Cn means cyanido. In some of the book you will find cyano. So it doesn't matter cyano or cyanido. Cyanido is the preferred one. Au, what should we write? For Au I told you, you will not write gold, we will write aurate, because a cation is present. So this condition is satisfied and we will write this as aurate. So it will become aurate, and the oxidation state -4 + 1, 4 - 1 3, it will give us 3. So cesium tetracyanido aurate 3. Now moving to K4FeCN6, we have potassium. So we will write down this with potassium. Next we have number of ligands, that is 6. We have hexa, and for Cn we have cyanido. For Fe we will write ferrate, just like here. A cation is present, this condition is satisfied, we will add 8, it will become ferrate. For oxidation state, I think -6 + 4, 6 - 4, that will give us 2, 1, 2. So here we are moving with all the cases. Try this at your home. Just bring out a pencil or a pen and some paper and write this down. And you should write this down. You should write down everything in chemistry before it flushes out of your memory. Now moving on to the next case, I think I should need to clean this up a bit. So the next case we have is NaMnCO5 and NaCO4. It is an interesting one because we haven't seen cases like this in our syllabus. Now look here, sodium, Mn, what do we name it? Manganese or magnate? This is CO. CO means carbonyl. So let us start. Na, it will give us sodium. 5 corresponds to penta, and CO is carbonyl, so pentacarbonyl, that is our sodium pentacarbonyl. Next we have is Mn, we will name it as manganate, so it will come manganate. Now moving on to the oxidation state, there is a twist in the tail. Look here, Na, then Mn, then 5CO, that will equal to 0. CO is neutral, so it carries no charge, that will become whole 0. Na is +1. So the answer while doing the maths is manganese comes in -1 oxidation state. There is a rare probability of having a minus oxidation state, but still possibility. So for minus, we will write down in the form of -1. So for this, you need to remember this, a positive oxidation state is common, but for a rare case we can have a minus oxidation state also. Try this at home, it is your homework. Now for the next case, look here, I will clean this up so that we can move on. Now for naming this, look here, we have two different ligands. So in order to name them, first of all, what we need to do, we have to name them in alphabetical order. Now what does the alphabetical order say? alphabetical order, say NH3 amine A. So it will come first, it will named first, and then this chlorido, because it is C, and there will be no distancing, there will be no pressing of space bar while naming the ligands. So the name is starting to be pentaamine chlorido with no spacing. This is cobalt, C-O-B-A-L-T, and look at the condition, an anion, sulfate anion is present here, so we will name it as it is, no cobaltate, only cobalt. Now the bracket, so if you calculate this, it will come out 3 plus 3, minus 2 minus 1, that will be minus 3, and it will give us plus 3. Do the maths. Now this is sulfate, we will write down as the name of anion will be sulfate. Done. Very simple. Now it will not be a good query for you, but look here, try to solve this. I am going to tell you this verbally. Triamine, trichlorido, cobalt 3. So we have all the cases here. Let us try some more cases. Let me just clean it up a bit. Now we have a case like CrONO6 minus 3 on this coordination pair. The condition is what? This condition. So while naming this, we have ONO. ONO means the bonding is done through oxygen. So the name will be nitrito O. O indicates oxygen is the species which is going to be the donor of electrons. So 6 we will write hexa nitrito O. Number of ligands, name of ligand. Now Cr, chromate, because this condition is satisfied. So CHROMATE, that will give us oxidation state ONO minus 1 minus 6 equal to goes there, and 6 plus 3, 1 2 3. For this particular case, you have to mention the name, the word ion, because it is in ionic state. So if it is given in ionic state, we will mention ion in the name. Now moving on to the next case, let us consider this ZnOH4 with 2 minus. Now if we consider this, we have 4 OH, so that will be tetra hydroxo. What should we name it? Zinc or zincate? The condition is this one, so we will name zinc 8 along with 2 minus 4, that will give us plus 2, and do not forget to write ion in it. So I think you get this. This is just the basics, the easiest question. Now we will try to do some complex compounds. So we will try some complex naming. I will clean this up so that I can write down some names. So I will catch you in the next clip. Till then, write this down, take a very nice screenshot, and before it flushes your memory, write this down. So we have a lot of questions here, and we will try to decode them one by one, and one by one. Now look here. For this particular case, we have 1, 2, 3, 6 ligands. All are different. So we will start to name in the order of alphabets. So first amine, then chlorido, then cyanido, then nitrito. Now triamine, then comes chlorido, then cyanido, and then nitrito with the N. Now look carefully, no spacing between the name of ligands. We have cobalt, and the oxidation state, look here, minus 1, and minus 1, that will give us plus 3, 1, 2, 3, done. Next we have this case. Try to do this by yourself. If you can't, then look here. Sodium first of all, then the next is amine, then next is bromido and chlorido. The leftover is nitrito with the N. Next is PT. It is what? Platinum. But we will not write platinum because a cation is present. It will become platinate. For the oxidation state, minus 1, minus 1, minus 1, plus 1. Do the maths, that will be 2. Moving to the next part, we have this NO. The cases of NO are super unique and super rare. Now, why NO is so unique? NO is a different type of ligand. It is an all-rounder. NO shows NO plus and NO neutral. For NO plus, we have the name nitrocilium. Or there is one other name, nitrosonium. But nitrosonium is been missing from the books. So, nitrocilium is one of a kind. Also, NO neutral, it is named as nitrosyl. Just nitrosyl. So, IUM for the cation. For the neutral one, we have nitrosyl. Now the problem is when to put up NO plus and where to put up NO, only NO. So NO plus is the common one. It is common one, and NO is rare, not rare, it is rarest. You hardly find 1 or 2 examples of NO being neutral, but there are examples. In most of the cases, NO is in the form of plus charge. I will tell you only one case in which NO is neutral. In most of the cases, NO plus will be present. Now look here. If we consider this, we will write down potassium. Next up we have 5-cyanido, penta-cyanido. Then we move on to 5-NO. NO is nitrocilium. Next we have is Fe, that will be written as ferrate. And oxidation state, look here, plus 1, minus 5, plus 3. Do the maths, 4 and minus 1, that will give us 1. Iron is 1 here. We have seen plus 2, plus 3. These are the common oxidation states. But iron do exist in plus 1. So this is the particular example. We have further more examples for that. Now moving on to sodium nitroprusside. The only question that has been asked in the IIT, as well as AIMS, as well as NEET. In all the 3 exams, in AIMS, it was asked what is the structure of sodium nitroprusside. Further, it was asked what is the oxidation of iron in sodium nitroprusside. And in the last exam, it was asked what is the IUPAC name of sodium nitroprusside. Sodium nitroprusside is an important chemical complex because it is used as a medicine for high blood pressure, and it is also used to test proteins, or we can say thiol group in proteins. That is why it has been asked frequently. Now the formula, Na2FeCN5 with NO. This is our formula. Now naming is not a tough nut. Let us start. We have sodium, then we have 5-cyano, that will be penta-cyanido. Then we have this NO, that will be written as nitrosyl. Now this time I am skipping IUM. Sometimes the examiner skips IUM and write down nitrosyl, and the student thinks it is neutral. So in many books it has been written NO nitrosyl, but it means that NO is positively charged. In the competition it was also written as nitrosyl. So don't get confused. There is a very rare probability that NO plus is written as nitrocilium. In most of the cases, in most of the book, it is written as nitrosyl. But to be exact, to be precise, to avoid confusion, nitrocilium is a better option if it is given in the multiple column section. Okay, now I will write down this nitrosyl because in our competition the option contains nitrosyl. Next we have is Fe. We will write down as ferrate. The oxidation state, +1, -5, +2, 3 minus 2, that will give us iron in +2 oxidation state. So this is an important one. The oxidation state of iron in nitroprusside is 2, as well as the nomenclature says sodium pentacyanide nitrosulfurate 2. Next is this one. It is brown ring complex. What is this? Brown ring complex, and it is formed in our test tube when we do test of nitrate ion. and it is part of our syllabus. And be ready for Viva, because your examiner will ask you this in your Viva. So this is the complex. In most of the cases the question is asked, what is the oxidation state of iron? Look here, +1, water is 0, and sulfate is -2. 2 minus 1, 1. So it will give us what? Fe in +1. So the oxidation state of Fe will be +1. This is the question asked. Now, what is the IUPAC name? This has also been asked in many exams. So FeH2O5NO SO4. Let us start with penta, aqua, water is aqua, look here. Next we have is NO, NO is nitrosyl. Finally Fe, Fe will be written as iron, not ferrate this time, because the condition is different. Iron, and SO4, sorry, 1, oxidation state is 1, and SO4 will be our sulfate. So this is how it is done. The most important question of nomenclature, if you ever study nomenclature, that will be the oxidation states and the nomenclature of brown complex, brown ring complex. I have written brown complex, it is brown ring complex, and sodium nitroprusside. Next we have Na4FeCN5NOS. It is also a rare question. Now I am talking about this rarest probability where NO is nitrosyl and it is neutral. So if you are trying to decode this, this will give us sodium. We have 5 cyano, that will be pentacyanido. NO is what? Nitrosyl, and S is sulfido. Last we have is the oxidation state. NO is 0, sulfido is -2, this is -5, this is +4, 7 minus 4, that will give us 3. So iron will be 3. Done. Next we have is Mn3CO12. For CO12 and 3Mn, Mn is 3, we will write trimanganese, and for CO we will write dodecacarbonyl. Dodeca corresponds to what? 12. Next we have 3Mn, that will give us trimanganese. The oxidation state being 0, that will give us 0. So these are the important cases. I have one particular case to discuss. Let me find the duster first. One more important case is this one. Look here, I will clean this up. No, you can reverse the video and take the screenshot, because you will forget them. These are hard to find. These cases are hard to find and hard to study also. Now look here, if I say I have Fe3, FeCN6 with a 4 here. So how will you name this? We have 2 Fe, the outer one, the cation will be named iron, and this one in the coordination sphere will be named ferrate. So the oxidation states, first of all let us break this in the classic pattern. Fe3 plus, okay, I just screwed it up. It will be Fe4, and from here it will be Fe3. Now look here, it will be Fe3 plus and FeCN6 4 minus. The basic cross multiplication, so that we get the charges on each of the respective atom or the coordination sphere. So Fe3 plus, that will be iron, and it has 3 oxidation state. We will write this down specifically 3. For this we have hexacyanide. This iron will be ferrate, and the oxidation state will be -6 and -4, that will equal to 2. So the answer is iron 3 hexacyanide ferrate 2. What about lithium aluminum hydride, LiAlH4? If you look here, it is like that. So it is also a complex. Hydrogen is tetrahydrido. Aluminate, we are using aluminate because here we have lithium. So lithium, I just forget to name lithium. So the name of LiAlH4 will be lithium tetrahydrido aluminate. Now sometimes our examiner asks us, name this AgNH3 whole twice and AgCl2 whole twice, and we have 2 different coordination pairs. So for this particular case, I will catch up you in the next video, and I will teach you some more interesting cases, the more complex cases. So keep learning, keep tuning. Till then, Keep watching.